Hi, today's lessons are continuing with trig identities and equations. This is going to be our first day of 2. We have gotten a lot more comfortable with reciprocal quotient and Pythagorean properties. You're probably doing better with common denominators as well now. The things that we need to focus on and practice a little bit more are probably splitting the fractions to maximize your, not maximize, but to make your steps happen. We haven't practiced as much with conjugates yet, but hopefully you remember this pattern, which gives us Pythagorean properties very often. Today we're going to add distributing and simplifying and factoring, both of which are Algebra 1 and 2 concepts. So we're going to now just throw in some algebraic steps. So the first things first is to prove that each equation is an identity. Remember, you can only simplify one side. Okay, and it's usually easier to start with the more complex side, which is our left side. Now, we used to go straight into reciprocal properties and just jump into them and write everything as a sine and cosine. However, it's important to recognize the reciprocal properties also state that if you have sine and cosecant, cosine and secant, tangent and cotangent, those two cancel out immediately and become 1. Now, the reason I say that is because if you look into your notes or at your example right here, if I were to distribute that, that would cancel out and become 1 right away, which paves the way for a Pythagorean property. So what we're going to do today is distribute because we can. So that gives us tangent x cotangent x plus tangent squared x. These two, this is our given, these two are a reciprocal property equal to 1. So we have 1 plus tangent squared x. That is a Pythagorean property. Okay. So, oh, sorry, I didn't do reciprocal property right away. I distributed first. Apologies. This is your optional step to write or not. And then this was the reciprocal property. Okay. 1 plus tangent squared x, hopefully you recognize this as a secant squared x. Okay. Which equals, and we can bring that down now, secant squared x. This was a Pythagorean property. We're done. Let's do number 6. So our goal is somehow to make this left side all equal to 1. Okay, so it means that something weird is going to happen. If it's going to equal to 1, either things are all going to completely cancel out. But what I notice about the left side is that they both have cosine squared x. So I'm going to do my given. And then underneath, I'll write factor GCF out. And our GCF is cosine x. You see how they both have a cosine x? Okay, so what I'm going to do is I'm going to write it with cosine squared x, apologies. And if I divide this one by cosine squared x, that leaves me with 1. And if I divide the second term by cosine squared x, I'll have plus tangent squared x. Okay. We just talked about that property. 1 plus tangent squared x is secant squared x. So this was a, let's see, Pythagorean property. And we know that cosine times secant is a, sorry, that looks like a Pythag. Simplify that a little. Okay, we know that cosine and secant equal to 1. This is a reciprocal property. This one, right? So then we have 1 equals 1. So far, so good? Let's keep going. So our last one is the one that's slightly different. We've talked about distributing, factoring out a cosine using GCF, and then this time these terms on the left and the right start to look very comparably complicated, but you always want to start with the one with the bigger exponents. Okay, so what we want to do now is notice that these are perfect squares. So what we're going to do is we're going to factor difference of squares. Do you guys remember that if I have a squared minus b squared, we can write it as a plus b times a minus b. So this is, a is going to be secant squared, okay, because when we split it, this is secant squared x times secant squared x. And this one is tangent squared x times negative tangent squared x. So we will have secant squared x plus tangent squared x times secant squared x minus tangent squared x. And now at this point you might be a little stuck. So here's our thought process. We want our goal to have only tangents, and we need a 1 somehow. If I need a 1, that signals to me that I should be using a Pythagorean theorem, because it's like 1 minus something. So I'm going to come to my list and notice that secant squared, if I only want tangents, I can use secant squared and change it or replace it with 1 plus tangent squared. So I'm going to take this one and replace that with 1 plus tangent squared x plus, I'll bring down my tangent squared x, and then this secant squared x will be 1 plus tangent squared x minus tangent squared x. Oh, I remember something. I copied this problem wrong. Sorry. Please change that to a positive permanently. It will not work if you don't have a positive. These two cancel. So let's see. We had given, our first step was factor, and then now we did Pythagorean property. We're going to simplify, and we get on the left 1 plus 2 tangent squared x, and on the right we will have just 1. Well, 1 times anything is just that thing, right? So we have 1 plus 2 tangent squared x, and that's what we want. What I did here was simplify, which you don't need to write. Okay, so just a few more tricks that you can add to your toolbox. Keep practicing with your homework and let me know if you get stuck on anything.